This video addresses the concepts of pH and pOH. In our world, daily we encounter different substances with varying acidity levels. We know that lemons are more sour, so therefore more acidic than grapes. So how do we represent how acidic a substance is? Well, introduce the concept of pH. A lowercase p. I know in probably previous science courses, you were instructed that the P stood for something, the power of hydrogen or the potential of hydrogen. Well, what we have to know moving forward is that when a lowercase p is in front of a variable, it means to take the negative logarithm of that. The pH scale is a way that we measure the relative hydronium or hydrogen ion concentration, because we understand that that is what is responsible for the characteristics of something being an acid. A logarithm is just a number cruncher, if you will, that allows us to take solutions that have such a variety of concentrations of hydronium, anywhere from negative 12 molar to 5 molar, and represent it in a scale that the average person can understand. So we know the pH scale has its midpoint at 7, and nature generally falls between 0 and 14, although in the laboratory setting, we can have substances that are above 14 and actually go into the negative realm. We know leading up to 7 on the pH scale, those are acids, and then above 7, those are bases. The lower in number your pH, the stronger the acid or the greater the concentration of hydronium. All that we need to do, if we know the concentration of hydronium, is simply plug it into the equation. And we know shorthandedly we could just write this as hydrogen ion. So if we have a strong acid solution, so let's say that it's 0.025 molar hydrochloric. Well, we know this completely will be ionized, and so in all actuality, we have 0.025 molar of hydronium or hydrogen ion. So to get the pH of that, we simply would utilize our calculator and plug in and do the negative log of 0.025 molar. Now, whenever you perform a logarithm, we want to increase the number of sig figs by 1. So if we do negative log 0.025, which has 2 sig figs, we'll report our answer with 3, which would be 1.60. All right. Now, what if we're given pH and we want to find the hydronium concentration? Well, logarithm is not a variable, it's a mathematical function. So if you're solving for hydronium, what we need to do first is divide both sides by -1 or multiply both sides by -1. So to make sure we make our pH negative. And then to undo a logarithm, we would take the inverse log or the anti-log of both sides. So I believe more commonly your math teachers call it the inverse log, or maybe 10 to the x, where x is your negative pH. Now, whenever we perform a logarithm, we increase sig figs by 1. So if we're undoing a logarithm, we would decrease our sig figs by 1. So if we would take the inverse log, let's undo what we just found, of negative 1.60, that will be our hydronium ion concentration. On your calculator, you would do second log. Second log. That's how we do inverse or anti-log or 10 to the x. Make sure that you're inputting your pH as negative 1.6. You don't have to put the 0 in there. And then put it into scientific notation or not. And this would be 0.03 sig figs. So I report only 2. And we just undid what we had just calculated. Okay, so pH scale is the perspective of the hydronium. But if we have water there, we know in the background, water is doing its own thing and creating hydronium and hydroxide ion. So even if we would call it an acidic solution, we know we have hydroxide there. And a basic solution, well, we know we have hydronium there. Well, pOH allows us to calculate it per the hydroxide concentration. And it's just the flipped version of pH. So for pOH, your bases will be below 7. The stronger the base, the lower in pOH, thereby the higher the concentration of hydroxide. Remember, lowercase p means take the negative log. And then above 7 would be acidic. The relationship of pH and pOH. This solution we found here had a pH of 1.60. Well, actually, that would be a pOH of 12.4 because pH plus your pOH, because of the relationship of Kw, is 14. So if we know pH, we can get pOH and vice versa. This should not limit your sig figs. So just like the relationship of Kw should not limit your sig figs, neither should this. So you're really determining sig figs based upon the decimal places of your pH or your pOH, or your molarity of your hydronium or hydroxide. Okay, so we have 3 equations that we can add to our arsenal. So these would be our pH equations, if you will. On the next couple of pages in our class packet, I really like this just very simple table because it really lays out for us not only common substances that we interact with, just to give us an idea of, when we say it has a pH of 3, what is that comparable to? Or 6, what is that comparable to? Or how about a pH of 12? But also I love this because it reveals to us that with every move from 7 down a whole digit of pH, we're actually increasing the concentration of hydronium tenfold because it's a log-based system. So something with a pH of 6 would have 1 times 10 to the minus 6 molar hydronium. pH of 5, 1 times 10 to the minus 5th molar of hydronium. We eventually get to 0.1 molar, and then 1 molar, and so on. So just interesting to have this layout revealing, the direct kind of relationship of log and concentration of hydrogen ion, and then we could continue down into the basic realm. Here's just a little bit of a different presentation. I just like this other grouping of common substances, but also this direct comparison of pH and pOH. Here are some other problems to try dealing with these go-to pH equations, and here would be my work and answers for these. Please do try these and then compare your answers. We often have a choice as to the path of problem solving, especially if more than one step is involved. And so I've hopefully laid that out for you. Sometimes, depending upon the path of problem solving, your number of sig figs can alter, but not in the case of what our givens were. Depending upon your path, though, because of rounding, your sig figs could deliver slightly different answers, but these would both be acceptable. So that is our presentation of pH.